So let's discuss this continuation topic under the design of compression members. Available strength in column load tables 1 based on effective length of the with respect to the y axis, so the KL. A procedure for using the tables with KXL can be developed as follows. Starting with the value of KL. KL was divided by RY to obtain KL over RY. The usual how to solve the slenderness ratio is that KL over RY, where RY is the minimum slenderness ratio, or the RY is the minimum radius of gyration, but we have also this KXL with respect to x-axis, because as we discussed with previous videos, the column is reinforced in the weak side of the column, so natay KXL over RX. In the design, starting with the value of KL was divided by RY to obtain KL over RY. Then FCR was computed, then the available strength, resistance factor times the nominal strength for LRFD, and TN over factor of safety for ASD were computed. Thus, the tabulated strengths are based on the values of KL being equal to KYL with respect to the y-axis. But we have also the available strength in column load tables 2. If the capacity with respect to x-axis buckling is desired, the table can be entered with KL is equal to KXL over the ratio of the radius of gyration with respect to x over the radius of gyration with respect to y. Yes, kung necessary nga we have kanang atong i-check gihapon ang buckling with respect to the x-axis, then compare ang whatever is greater atong effective length kadto ang mo-govern sa design. Also in the table pwede siya nga you can also compute the table through this relation. The KL is also equal to KXL over RX over RY, and the tabulated load will be based on KL over RY is equal to KXL over RX over RY or over RY, or just equal to KXL over RX. The ratio RX over RY is given in the column load tables for each shape listed. So katong table we have different shape, then we have the value for the radius of gyration along x-axis and y-axis. So kato siya ratio ato dito siya makita sa table. To better understand this atong gistorya diri we have this example. The compression member shown in figure is pinned at both ends and supported in a weak direction at mid height. A service load of 400 kilopounds with equal parts of dead and live load must be supported. So meaning equal parts of dead load and live load, meaning 200 dead load and 200 live load. 400 man siya. Use Fy is equal to 50 KSI and select the lightest W shape. We have here the column, then na siya support at with direction. So at mid height we have 9 feet. I think this is feet and 9 feet. First is we have to compute for LRFD solution, we have to compute the factored load no, PU. 1.2 dead load plus 1.6 live load. So this load combination will give the highest value, critical value for your factored load. So this load combination will govern in the design. Then assume that the weak direction controls and enter the column load tables with KL equal to 9 feet. Beginning with the smallest shapes, the first one found that will work is W8 by 58 with a design strength of 634 kilopounds. So kani siya, if you see in this figure, no, we assume that the weak direction controls, no, gi-assume nato nga the value of the effective length is this weak direction. So meaning this weak direction is the half of the column supported at mid-height. So mo nang KL, since the support are both pinned, no, connection, so meaning the K is equal to 1.0. So we assume nga ang KL nimo is equal to 9. So tan-aw na to siya sa table, beginning with the smallest, no, beginning with the smallest shapes, no. If you try to look at in the table, beginning with the smallest shape, dire. So we have here a table 4-1, no. This first column is the KL, beginning with the smallest. So actually kani siya is ang highest ani is W14, no, ang yang depth. Ang smallest ani niya is W8, meaning 8 ang iyahang height, no, 8 inches. So remember the KL, we assume nga we base on our effective length, we assume nga at weak point, meaning half, no. So KL is equal to 9. So kung tan-aw na to, dapat mo greater than siya sa computed nga factored load, no, is slightly greater, no. So if we try to look at in the table, W8 and 9, no, naara man tong 9. Here is the 9. Dayon PU is equal to, pilag ito? 560. So, kung 560 LRFD, so we have this one, di ba? 634, no? W8 by 58. So, say, the first one found will work W8 by 58 with design strength, no, in the table of AISC manual is 634 kilopounds, no? Then check the strong axis, no? Since first is we assume in the weak axis, weak direction, KL is equal to 9 feet, di ba? Then karon, since we choose the the section as W8 by 58, we will check now the strong axis. Tan-aw na to kung ang kaning W8 by 58 is ang iyahang KL is greater than or equal to the 9 feet that we assumed earlier. So kung tan-aw na to, we have to determine the value of the R sub X and R sub Y, the radius of gyration. So tan-aw na to sa, kato siya ganina is 4-1 mo to, tan-aw na to sa table 1-1, no? Unsa tong member? A member is, the kuan is W8 by 58. So, we try to look at in the in this. So, nara, W8 na sa ubos, no? Haman to. 12, ay, okay. W6, W8 by 58, no? Naa siya diri. Kani W8 by 58, so wala diri ang radius of gyration naa sa next table. So W8 by 58, kani, no? And the radius, wait. And, sorry. And the radius of gyration for x-axis is 3.65, and for y, we have 2.1, no? 2.1. So the ratio of that 3.65 divided by 2.1 is 1.738, no? So balik ta sa problem, 1.738, or in this example is 1.74. No? Check the strong axis. So kung tan-aw nimo sa kuan, the strong axis is this whole length of the compression member, 18 feet, no? So 18 divided by this ratio, Rx over Ry, is 10.34, which is greater than 9 feet, meaning this strong axis will control, no? The KXL controls for this shape. Then, based on this value, the KXL, which is 10.34 feet, dayon A8 by 58, atong tan-awon again sa table, the 4-1 table. Remember, the KXL is equal to 10.34. As you can see here, this is the KL. These are the value of the KL, no? They have the 0.697. Wala kay makita nga 10.34. So what we're going to do now is to interpolate, no? The shape is W8 by 58. Then, since the value of KL is 10.54, so between aning 10 og 11. Then, interpolation, you know already how to interpolate, di ba? We have this value, 34, by 58 man, so we have this 606 and 756. Say that is 10.34, then 11. Then the value of the design strength, no, is 606, and we have, say, we'll set x, then 576, no? So by interpolation, we have x minus 606 over 576 minus 606 is equal to 10.34 minus 10 over 11 minus 10. So the value is 576. 10.34 minus 10 over 11 minus 10. The value is 595.8. Sakto ba? Okay. By interpolation, we have this value 595.8 or 596, which is greater than the computed factored load. So, maunang, okay. Pero kung less than ganit ni siya, meaning not okay, so dili siya pwede. Of course, we have to check for another shape, no? Kay kung ano man atong i-check, W8 by 58. We have to check for another shape nga, because we are required to determine or select the lightest W shape. So, aside sa W8 shape, we have also, since the smallest is W8 to W14. Now, we have to check for the next shape. So, next is investigate the W10 shape. Try the W10 by 49. Since our KL is, we assume again nga KL is 9 feet. So, kung tanaw nimo sa W10, no, to tag W10, then we have KL is equal to 9. dapat greater than siya sa 560, di ba? The factored load, 560. If I try to look at here, we have this W10 by 49. This is 9, and the strength is 568, which is greater than 560 kilopounds. So, manang we'll investigate next is W10 shape. We try the W10 by 49 with design strength now, according to table, is 568 kilopounds. Then we again check for the strong axis. So, tanaw na po nato, no? Using this shape, W10 by 49, we have to see the Rx, radius of gyration along x-axis, and radius of gyration along y-axis. Then, compute for the ratio, no? So, kung atong tanaw, no, the same procedure for W8 by 58. Next is, we'll check the W10 by 49, no? Then, wala man diri ang next table is W10 by 49 is the radius of gyration is this 4.35 and 2.54. So the ratio of that divided by 2.54 is 1.713, or in here, no, in the example, 1.71. Kung imo siyang solve, that is greater than 9 feet. Still, the strong axis will govern, no, this kx, or the strong direction will govern in your design or controls for this shape. Then we have to again enter the tables with KL is equal to the new computed KL, no, just 10.53. Then, tanaw na to siya kung mupasar siya or mo greater than siya sa 560. Again, in the table, wala siya exact na 10.53 value. We have again to interpolate, no? Interpolate. So, tanaw na to ang W10 by 49. Pila to? 10.53, di ba? We have here, again, interpolate. So, I believe, no, you know already how to interpolate. We have 10. That is between 10 and 11. W10 by 49, the value is 550 and 532. No? We have 550 and 532. So, the value of that now by interpolation, so diretso na lang ta, is equal to 594. Next, investigate W10 shape, then again, control the enter tables with KL 10.53. So, atong tanawon, I think diretso siya dire. 560. Okay. Alright. Dire. Kung tanaw nimo, di ba we'll try to interpolate man, di ba, the value. But, remember, the factored load value is 560. Kung tanaw nimo ang W10 by 49, no? W10 by 49, between 10 and 11, since the KL is 10.53 man, the computed KL. Between 10 and 11, kung tanaw nimo, the value for the design strength, no, is, for 10 is, KL10 is 550, and for 11 is 532, which is less than 560, meaning automatically, this W10 by 49 is not good, no? So, di na siya pwede, X na siya, no, already. So, the next lightest W10 shape is W10 by 54. Then, again, we we try to the same procedure, no? Then we'll try to check the strong axis for that. Then interpolate, no? With interpolated design strength, the value, no? Using interpolation. So, kung tanaw na to ang W10 by 54, the next nga greater than kuan is 560. So, sakto W10 by 54 ang nagsunod. So, we'll again try, no? We'll try to check this W10 by 54. So, kung ato siyang tanawon sa table, W10 by 54, this one, no, by W10 by 54. W10 by 54, the value of Rx is 437 and Ry is 256. Try to solve for the ratio 437 divided by 2.56. That is 1.707 or 1.71. No, 1.71. No, mura gyapon siya 1.71. Again, kung ato siyang himoong 1.71, the value of KL is 10.53. Then, using the table 4-1, we again try to interpolate, no? We have 10, 10.53, 11, then W10 by 54 naman to, then LRFD, we have this between 605 and 585, no? 605 and 585. So, what is the value of the design strength at KL 10.53? So, by interpolation, no, diretso na lang ta. Kamo na lang interpolate, no, by, kung mag-study mo, we will get this value, 594 kilopounds, which is greater than 560. So, okay, this is also okay. Then, we again continue searching, no? Continue the search and investigate using the W12 na punta shape. Then, we assume nga KL is equal to 9. The lightest, no, shape sa W12, lightest shape nga mo greater than siya or slightly greater than the factored load W12. Kung tanaw na to, KL, we assume value of KL9, no, using the weak direction. 560 is, we have this one, no, W12 by 53 or pwede ka W12 by 58. So, we try this W12 by 53, which is continue the search and investigate a W12 by 53 with a design strength 611 kilopounds. Then, the same procedure, we solve for the this ratio, the KXL or KXL, using the other table, no? Katong table of properties with radius of gyration. So, kung tanaw na itong W12 by 53, the same procedure, no? W12 by 53. This one, no? W12 by 53, pero wala man siya radius of gyration. So, we try to see the next table. We have radius of gyration 5.23 and 2.48. So, solve for the ratio. We have 5.23 divided by 2.48. We'll get 2.1. 2.8 na siya, or in here we have 2.11. So, solve for that. We'll get 8.53, which is less than 9 feet. Meaning, since mas gamay man ang sa strong direction or strong axis, meaning the 9 feet, which is in the weakest direction, weak direction, will control, no? The KYL controls for this shape with already, since 9 feet naman imong gi-assume atong 611. So, manang design strength is 611 kilopounds for this W12 by 53. Then, again, no, wala pa man tanahuman sa table because naapatay W14, no? Determine the lightest W14 na punta, which is the last table. The lightest one with the possibility of working is EW14 by 61. It is heavier than the lightest one found so far. So, it will not be considered. So, tanaw na po na to ang W14. Now, remember, we assume again the weak direction, which is the KL equal to 9 feet. So, kung tanaw na to, W14 is W12. Dilita no, W14 with KL equal to 9. So, kung tanaw na to, remember the factored load is 560. No? 560. So, pwede taaning W14 by 61. With LRFD, no, factored load 699. Greater than 560, the factored load, no? So, we'll try to check the KL for the strong axis, no? So, remember, no, timan AW14 by 61, atong pangitao ng RX o RY, then get the ratio to solve for the W14 by 61. This is W14 by W14 by 61. So, kani siya, no? Pero wala man tayo radius of gyration diri. Dito sa next table. W14 by 61. Radius of gyration along X is 598. And along Y is 2.45. Kung atong tanan ang ratio, 5.98 divided by 2.45. 2.44. So, atong so, the value of the strong axis for W, the K or KXL over RXRY, what man ko ka? That is 18 now for strong axis divided by the ratio is 2.44 according to the value of radius of gyration. So, the answer is, pila man ni 18 divided by answer, that is 7.37, which is less than 9 feet, no? Still, the strong axis or the KYL will control in the shape. So, meaning, the value of the K14 by 61 design strength is 699 kilopounds, which is greater than 560, the factored load. Dayon, kung tanaw ni mo, 61 ni siya, pound per foot. Then, comparing to the other shape, ang una na to na check is iba W8 by 58, no? Next is W10 by 49, pero wala man ni siya ni pasar. This is not good. Then, we have W10 by 54. Nipasar siya. Then, we have W12 by 53, which is okay. Gihapon. Then, the last is W14 by 61. But, comparing those shapes, no, the lightest is actually this W12 by 53. Kay 53 man. This is pound per foot man. Muna siyang pinakagamay, di ba? The last is 14, W14 by 61. Mas dako man siya compared to 53. So, munang we have this final answer, W12 by 53. This is the lightest, no, shape that will comply, no, or that will resist this surface load. That is for LRFD. Next is we'll discuss